Okay, in this video we're going to look at inverse cosine trig functions. So as we've talked before, in order to have an inverse function, the function cosine needs to be 1-to-1, which means it needs to pass the 1-to-1 or the 1-to-1 test or the horizontal line test. So if you look at this, if we draw a horizontal line, it touches the graph more than one time, which means it's not 1-to-1, which means it doesn't have an inverse. So we can restrict the domain of this to where it is a 1-to-1 function. So in this case, let's restrict it from 0 to pi. That means we're not going to even worry about things on the outside, only restrict it from 0 to pi. This leaves us a function that is 1-to-1. If we tried the horizontal line test, it would only cross one time. So we're in good shape, and we can get an inverse cosine function from this as long as it's restricted. So if we look at cosine, we've restricted the domain to only between, 0 and pi. The range, just like on sine, goes from -1 to 1. Okay, so now we have a 1-to-1 function as long as we use this restriction. So if we want to look at the inverse function, we switch the domain and range. That means our domain of our inverse cosine would be -1 to 1, and our range would be 0 to pi. So remember, inverse cosine will produce an angle, and our angles will be somewhere between 0 and pi. Let's look at this on the unit circle. Here we have 0, here we have pi over 2, and pi. So in this case, for cosine, we are restricted between the quadrant 1 and quadrant 2. Okay, so for cosine, quadrant 1 always produces a positive trig value. Quadrant 2 always produces a negative cosine value. And one more thing just to remember, when I ask you for the inverse cosine, that is the same thing as the arc cosine. They just represent the same thing, just sometimes they may ask you, either way. As long as you know they mean the same thing, we're good. Let's look at some examples. Okay, number 1, we have the inverse cosine of 1/2. So we can rewrite this because we're looking for theta. We can rewrite this as the cosine of theta equals 1/2. So we're looking for what angle theta gives us the positive value of 1/2. So let's look at our chart over here. Where is cosine equal to 1/2? So we have 1/2. We have cosine right there, and that happens at pi over 3. Okay, so my theta, or my reference angle, is pi over 3. So remember, we just need to look and see. My cosine in this case was positive, and we know that that happens in the first quadrant. Right there, our angles are between first and second quadrant. So pi over 3 would be right here. So my answer is pi over 3. Okay, let's look at number 2. Let's see, we have the arc cosine of -1. So let's rewrite it. That's the same thing as saying the cosine of theta equals -1. Okay, so let's see. My cosine gave me a negative value, which means it's going to end up in quadrant 2. So let's look over at our chart. Where is cosine 1? So here's 1. My cosine is 1 at 0. Okay, so now let's think about this. If we restrict it from quadrant 1 and quadrant 2, remember cosine, if you remember all students take calculus, where is cosine positive and negative? Cosine is positive everywhere, and in the first and fourth, and it's negative in the second and third. But remember, for inverse cosine, we don't even worry about the third and fourth quadrant. We have first and second. So when we end up getting a cosine that's negative, we know it is quadrant 2. So this angle is quadrant 2. Well, we ought to know this. The cosine is -1. This actually falls right here at pi. Just remember on our unit circle, pi is at the point -1, 0. Right? And we know that represents cosine and sine. So when I had the cosine of theta equals -1, we know it happens at pi. My answer for theta is pi. It would have been 0 if cosine had equaled +1. So just remember, if cosine equals a negative, you're going to do quadrant 2 angle. If cosine is a positive, your angle will come from quadrant 1. All right, let's look at number 3. The inverse cosine of -√3/2 equals what? Let's let that be theta. So let's rewrite it. That is saying the cosine of theta equals -√3/2. Okay, as we know, because we got -√3/2, we know our angle is somewhere in quadrant 2, somewhere over here. Okay, so that would be our theta. We just need to find what that theta is. So let's look at our reference angle. Our reference angle from over here on our chart would be, let's see, where's cosine squared of 3/2? So here we have cosine. Square root of 3/2 happens at pi/6. So our reference angle is pi/6, which means it's right here in our reference angle part. But our angle, our second quadrant angle, we have to write it in standard form. And so in that case, our quadrant 2 angle would be 5pi/6. There's our answer. Okay, let's look at number 4. We have the inverse secant of -2 equals theta. Let's rewrite it. The secant of theta equals -2. Okay, so we want to work in terms of its reciprocal. We know secant and cosine go together. So if we rewrote this in terms of cosine, remember we need to flip it. That would be the same as -1/2. We flipped 2/1 to 1/2. Okay, so where's the cosine of theta equal to -1/2? Okay, we get a negative. We know that. So we know that it's restricted, right, between 0 and pi. Since cosine right here was negative, we know it's going to be a quad 2 angle. So this is quadrant 2. Let's see, quad 2. All right, we need to find theta. Let's use our reference angle. Where's cosine equal to 1/2? So if we come up to our chart, cosine, right, equals 1/2 at pi/3. So we have pi/3 is our reference angle. But since it was negative, we need to write quadrant 2. We need to write the standard angle of quadrant 2, and that would be, let's see, it's over 3. That would be 2pi/3. There's our answer. And finally, let's look at number 5, the arcsecant of square root of 2. So let's rewrite that. The secant of theta equals square root of 2. So let's find what theta, when we take the secant, equals square root of 2. So let's rewrite it in terms of its reciprocal, secant and cosine. They're reciprocal, so we can flip this and have it 1 over the square root of 2. All right. It is positive, so we know this would be a quadrant 1. Let's see, I'll put it over here. We have a quadrant 1 angle, right? Because it's positive, so it's somewhere over here. All right. Now, if we want to look this up on our chart, let's see, I need to erase this from the previous example. And we can look it up. Now, 1 over square root of 2, we really don't have that on there. That's because the values written on my chart are rationalized. So let's rewrite 1 over square root of 2 down here. Let's write it in rationalized form. That's the same as the square root of 2 over 2. Now we can look it up. Where is the cosine equal to square root of 2 over 2? Square root of 2 over 2, here's cosine. That happens right here at 45 degrees or pi/4. Since it's positive, we know my answer is simply just the reference angle. So my theta is pi/4, which is also this angle right here. It's pi/4.